Good afternoon, everybody. In this video, we're going to find out what is the acceleration due to gravity above the Earth's surface. In the other videos, we have calculated the acceleration due to gravity near the Earth's surface or on the Earth's surface. But if you are very, very far from the Earth's surface, what would be its value? That's what we're going to calculate. In fact, we're going to derive an equation for it. So let's get into it. So what are the given values? We already know that the acceleration due to gravity on the Earth's surface is 9.81. That's the average acceleration. And now we are interested in finding the acceleration due to gravity at a height 500 kilometer from the Earth's surface. And the radius of the Earth is 6400 kilometer. So let's first write down all the important numbers. So G value is 9.81. What is this G value is? This value is acceleration due to gravity on the Earth's surface. Height from the Earth's surface is 500 kilometer. So you have to convert into meter. Every time when you do the math, you have to convert into SI system. So kilometer is thousands or 10 to the third meter. So again, I'm doing the same thing. The radius of the Earth is 6,400 kilometer, and I'm converting into the meter. So now I have to measure the distance between the center of the Earth to this mass here. So how do I measure? It would be the radius of the Earth plus the height, r plus h. So if you do this math, the number will be 6,900 times 10 to the 3 meter. So now let's write down the equation for calculating the acceleration due to gravity. The acceleration due to gravity equation is this equation, G equals to gm over r squared, and this equation is on the Earth's surface. Now, if the object is at a height, so how do we calculate then? In that case, all we're going to change is this r would be simply replaced by this r. So here, if the object is right here, then you use this distance. But if the object is at this point, then you have to use this distance here. So the distance between the two objects. That's what I have used here. And G equals to gm over r squared. So as the r is the radius of the Earth, that means this equation is for on the Earth's surface. Now here r is at this height here. You see this height here? That's the distance between these two, Earth and this point. So that means that is the acceleration due to gravity at that height. So now we have written down the equations. Now in order to find out the values, we can simplify these things. So I'm simply dividing equation 2 by equation 1. So GH over H. So GH is GM over R squared. And this G value is GM over R squared. So these two cancels out. And if I solve, it will be R squared divided by a small r squared. So you see now this is a pretty straightforward equation. The other way you could have done is plug in this value. So you have to do a lot of calculation, but this way it's much easier. So r squared over r squared. So now if I solve for the acceleration due to gravity at a height, or gh, so let me just write down one more thing here. It has to be gh, this should be gh, and this should be gh. So now if I solve for gh, it will be g times r squared over r squared. So now we know all the numbers here. The g is acceleration due to gravity on the Earth's surface, which is 9.8. R is the radius, and r is the distance between the Earth and the point at a height, which is 6,900. So we just have calculated everything here. You see, 6,900 kilometer. So if I plug in, what the value I get is 8.43 meter per second squared. That means at a height of 5 kilometer, 500 kilometer from the Earth's surface, the acceleration due to gravity would be this much. What does this number tell you? This one tells you the acceleration due to gravity is not a constant quantity. It does change from position to position. The further you go from the Earth's surface, this value would go down and down. In fact, it follows the inverse square law. So you see, it follows the inverse square law. That means it is a quadratic. It follows the square law, inverse square law. So if you plot a graph, in fact, it would go just like this. Okay, that's a separate thing here. But now let's calculate what is the percentage change. So if you calculate the percentage change, the equation for percentage change is final value minus initial value divided by the initial value. The final value, which is at a height of 500 kilometer, is 8.43. The initial value we have measured as our reference value is on the Earth's surface, which is 9.81. So if you plug in and solve for it, the number you will get is 14.1%. That means compared to the Earth's surface, the percentage change at a height of 500 kilometer is 14.1%. So this is it from this video. If you have any questions, any comments, write down in the comment section below, and do not forget to like, share and subscribe the channel. Thank you very much.